Good afternoon, students. So once again, we are here to discuss a new topic in information security that is known as a data encryption standard. Okay, so as you know that in order to secure a particular information in a system, we require some particular techniques that how we can protect our systems. So basically, we can say like this that in this particular encryption, these techniques like we have some of the techniques related to the substitution part and some of the techniques related to the transposition part. Okay, so in substitution parts we need to just substitute a particular alphabet with some new alphabet, and in the transposition part we just rearrange all those elements. So data encryption standard technique is one of the way in which we are encrypting a particular plain text into such a ciphertext so that a third party or a hacker or intruder doesn't able to assess that particular plain text or the original text. So there are some features that we need to discuss regarding this data encryption standard part. First one is that just follow the concept of a block cipher. So whatever the ciphertext that you will be getting, that will be in the form of a different blocks. So blocks is a collection of different bits that we can have, and we also convert a particular plain text into different blocks part. And obviously, after doing all those calculations, whatever the text that we will be getting, that will be also in the form of a that is a block ciphertext that we will be getting. Second feature is that this is a one of the symmetric cipher. So our DES, that is data encryption standard, that it will follow a method of symmetric cipher. So what we mean by a symmetric cipher text is that we use the same key for the encryption part and we use the same key for the decryption. Okay, so second part is that we are using same key for the encryption part and same key for the decryption part. That's why we use the concept of a symmetric cipher. Third feature is that it will be using 64-bit plain text block. Plain text block. Okay, so what we are saying over here that it will be using 64-bit plain text block. So what should be the size of a plain text? That should be 64-bit, and we need to divide this particular plain text into the different blocks over here. Okay, so we are having 64-bit plain text box over here. Fourth feature is that it follows 16 rounds. 16 pistol rounds will be there. Okay, so it will be using that 16 pistol rounds over here. Now, what is the purpose of it? Like in 16 rounds, it will be encrypting your data. So these particular round is known as a pistol round. Okay, so all these particular rounds will be known as a pistol round. So I just repeat the different features of data encryption standard part, and same features we will be implementing shortly. So the first thing is that the first feature of data encryption standard part is that it follows a block ciphertext, that it will just generate a block ciphertext. That means whatever the ciphertext that we will be giving it out, that will be in the form of a blocks. Okay. Second is that it will follow a symmetric cipher technique. That means we are using same key for the encryption part and same key for the decryption part. Third is that it will be using a 64-bit plain text block. Okay, so it will be using a 64-bit plain text block as a input. Fine. Fourth part is that it will be having total 16 rounds that will help you out to generate a ciphertext, and each round that we will be using here is known as a pistol round. Okay, so that will be known as a pistol rounds. Now, coming to the basic structure of this DES, that is data encryption standard technique. So here you can see that we are having 64-bit plain text over here. Okay, so whatever the input that we will be having over here, we will be converting that particular input to the 64-bit plain text. Or we can say that the main rule of this data encryption standard technique is that whatever the input that we need to give, it should be the size of 64-bit plain text. Okay, After that, we will perform some initial permutations over here. So what we mean by permutation over here, that is mean the rearrangement of the letters. Okay, so we will be doing some initial permutation over here on this 64-bit particular plain text. After that, we will follow a total round of 16 rounds. We will be following that 16 rounds over here. That is a pistol round. So that pistol round will help us in order to get that particular ciphertext. How this particular rounds will be incorporated in this data encryption standard part is that we will be using a key over here, that is known as a 48-bit key we will be using. So these rounds will be implemented with the help of a key which is a 48-bit key over. So initially this key will be of 64-bit. Then we will convert the 64-bit key into 56-bit, and after that 56-bit we will be converting it to the 48-bit. Right? So firstly we are having 64-bit, then we will convert it to the 56-bit key, and after that we will be converting it to the 48-bit. This particular 48-bit key we will be using in each round. So each round will be having its unique 48-bit key. Okay, so each round will be having its a unique 48-bit key with itself. And after doing all those rounds over here, total rounds are 16 rounds. So after the 16th round, whatever the output that we will be having, we will again have an inverse initial permutation here. Okay, so again we will be doing some inverse initial permutations over here, and we will be doing it on the output that we will get after the round number 16. Okay, and finally whatever the answer that we will be getting here is that is a 64-bit cipher text. Now this is the main general structure of your data encryption standard part. I again repeat that what is the basic structure of your this data encryption standard part. So the first thing is that whatever the plain text that you will be getting over here, that should be of 64-bit plain text. Okay, that will be your 64-bit plain text that you will be having here. Okay, this is the initial requirement for this data encryption standard part. After that, we will perform some initial permutations on it. What we mean by permutation, that means the rearrangement of the letters. Okay, so we will be doing some initial permutations over here, and after doing all those permutation, we are getting different rounds of this cycle here. Okay, so we will be performing different rounds of the cycle here with the help of a 48-bit key. How we will be getting that 48-bit key over here? Initially, the key size will be 64-bit. We have converted it to 56-bit, and then we have converted 48-bit. How we have done all this process that we will be discussing in this particular session. Okay, and doing all those rounds, we are having inverse initial permutation. Then we have inverse initial permutations over here, and whatever the result that we will be getting over here, that is a 64-bit ciphertext. Fine. So that will be a 64-bit ciphertext. Just remember that whatever the 48-bit key that we will be using here, this particular key will be different for each and every round. Okay, that means total 16 rounds will be having different 48-bit keys. Its size will remain the same, but the structure of each and every key will be different. Clear? So this is the main idea of your data encryption standard part. Now we will start discussing this particular algorithm in detail by using different algorithms. So one by one, the main thing that we need to discuss over here is that it's okay that we are having 64-bit plain text here. We will be performing any type of permutations over here, like the rearrangement of the letter. The main work will start from this part, that is a round part. Okay. Now, what type of a round structure that we will be using here? That is a crystal round structure. So we will discuss in detail that how this crystal round will work, and one by one we will be discussing its structure. Okay. So we will discuss the main important part of this data encryption standard is that pistol round. Pistol. Okay, this is your pistol round. These are that particular rounds. How many rounds we can have in my data encryption standard part? That is the 16 round. And each round is known as a pistol round. So how pistol round works? Like it will be having that 64-bit. I just make it on the one side of the blackboard because after that I have to explain each and every part of this pistol round also. Okay, so I will start like this, that it will be taking 64-bit data as input. Okay, now what we will do, we will divide the 64-bit data into two parts. So that is left 32-bit and right 32. Right 32. Okay, this is your left 32-bit, this is your right 32. Fine. Now, what will happen? This on this particular right 32-bit, what we will be doing here, we will be performing a function here. We will be using one function here, that is f. There will be one function here, that is f, and what we will be doing here, this particular part, this is a left 32-bit part, and this function part, we will perform that exclusive OR function. Okay, so we will be having exclusive OR function on the combination of the output that we will be getting after implementation of this function on this 32-bit. Okay, so that's output, and this left 32-bit directly, we will be performing that exclusive OR function. Fine. So whatever the output that we will be getting here will be my new write. That will generate the new write part here, that is the 32. Fine. And this write 32-bit will directly become my new left 32. New left 32. Clear? So this particular part, now when you have performed this particular function, you will be requiring one key over here. That is a 48-bit key that you will be using here. 48-bit key, that is key 1 that you will be using here. Okay, I will again just repeat this part. Just listen it to this very carefully, because after that we will be discussing each and every part of this particular pistol round. So the very first step of the data encryption standard is that we will be getting that blocks of data in the size of a 64-bit. After doing initial permutation, we will just send this particular data to the rounds part. So total we will be following 16 pistol rounds here. Now, how all these rounds work upon? This is the first round that we have discussed so far. This is your first round. So, how we have implemented? Like, we will be having 64-bit data as an input to this particular round part. So, we will divide the 64 part into two parts. One is the left 32 bits and another one is the right 32. Fine. On this particular right 32-bit, we will be using one component over here that is known as a F. Okay, with the help of a key also. So there are two inputs to this function part. One is a right 32 bits and the another one is your key over here, that is a 48-bit key. So we are defining that particular key as a key 1. Okay, because if you remember, I have already told you earlier that for each round we will be having a unique key over there. So this is my key 1 here. So both this combination will be given to the function part. After doing all those set of processing over here, whatever the output that we will be getting here, again that particular output and directly that left 32-bit, we will be performing exclusive OR function. We will be performing exclusive OR function. Okay, and whatever the output we will be getting here, that will be my new write 32. Okay, and directly your right part will become your new left part. Okay, so this will be your first round here. This will be your first round here. Again, on this new right part, what I will do? Again, I will use that function component plus another 48-bit key. 48-bit key will be there, that is key 2. Again, 2 inputs to this function. It will give you one output, and we will exclusive or that particular output by this new left 32. Okay, we will perform that exclusive or function over here. Now, again, what will happen over here? Whatever the output that we will get here, it will become my new right. New right, that is of 32. Now you have completed your second round here with a different key, that is key 2. With a different key, that is key 2, and again directly your new right will be your new left 32. So on, you have to perform all this part 16 times. Okay, so 16 times you will be performing all this part of it. Fine. So this is your pistol rounds or the pistol structure that we are talking about. This is your pistol round or a pistol structure that we are talking about. Now, what is this F part over here? Okay. Now, we will discuss one by one the components that we will be using in this pistol round, which is the one of the important part in this data encryption standard. So, first of all, we will define the term here, that is function definition. Function definition. For your convenience, I just again repeat these points. Now, again for your convenience, I will again repeat all these points. Just listen it carefully, because then only you will be able to understand the next part. So what we are discussing here, that is a pistol rounds. So total we need to follow 16 rounds over here. Now how all these rounds will work upon, like we are having 64-bit data as an input over here. We have divided this 64-bit data into two parts. One is the left 32-bit and another one is the right 32-bit. What we are doing here on this right 32-bit part, we are using one component here, that is the F component, and with the help of a particular key, that is a 48-bit key over here. So we are performing all those calculations on this function part, and whatever the output that we will be getting here, we will exclusive or with the left part. So whatever the output that we will be getting here will be my new right part, and directly that right 32-bit will now become my new left 32. Clear? So on, we will be doing all these rounds at the total time of the 16 rounds. So at 16 times, we will be performing all this. Now, what basic part belongs to this function part? So in this function definition, you can see that what we are having one input over here, that is 32-bit data. So we are having a 32-bit data here. Inside this function part, we are having another part here, that is an expansion block. Expansion box. Now, what this expansion box will do, if you see it clearly here, that here your data is 32-bit, but what key you are having here, that is of 48-bit. Okay, so this is 32-bit, this is 48-bit. You need to convert this 32-bit part to the 48-bit part, so that whatever the output you can get, you can combine on this both the systems. Okay, so we will be using Okay, so you can see over here that is a 32-bit data here, but you are having 48-bit key. What we want, we need to match the size of both the parts. So inside this particular function block, we are having one expansion block that will expand your 32-bit data to the 48-bit data. Okay, that will expand your data into 48-bit data. Now, what you have done in this particular part, that you are having an exclusive OR part over here, and here you will be getting a 48-bit key. 48-bit key, that is K1. Okay, so we are having 48-bit key, that is K1 here. Clear? 48-bit data, so we are having 48-bit key, that is K1 will be here. Now, after doing all this exclusive OR operation on both the paths, that is the data that we have received after passing my data to the expansion box, so we have matched that size over here. Inside this function box, there is an expansion box that will convert your 32-bit data to the 48-bit part. Okay, and you will combine that particular key over here, that is a 48-bit key that you will be having, and doing that exclusive OR function, you will be getting the output in the form of 48 bits. Okay, again your output will be 48. Now again, you see that whatever the output that you are getting, that is again in the form of a 32 bits. So again your 48 bit will goes to one another box over here, that is the substitution boxes. So we are having total 8 substitution boxes over here. Okay, so this is your total 8 substitution boxes. So S belongs to substitution boxes here. Substitution boxes here. Fine. So after doing all those calculation under this substitution box, we will be getting the output as 32-bit data. Okay, so we will be getting the output in the form of 32-bit data. Fine. So after getting this particular implementation, we will be getting 32-bit, and again on this 32-bit data, we will be performing a permutation box will be there. Again, there will be a permutation box. So I hope you understand the term permutation, in which you will be performing all those rearrangements of the letters. So we are having permutation box over here, and finally we will be getting 32-bit as a output. Clear? So just remember both these diagram, and if you have time, you can just draw it side by side. That will obviously help you, because still we need to discuss so many things that belongs to both these diagrams. So here I just again repeat for you people. So here we need to discuss the pistol round. So pistol round will be having that 64-bit data. We have divided this data into 2 parts, left part, right part. This right part will goes to this function box, and this function box will be having a key also, and this combination of a key by performing exclusive OR with that left 32-bit part, whatever the output that we will be getting here, that will be my new right over here. Okay, and directly your right 32-bit will become your new left. This is just regarding the crystal rounds. We have to perform all this calculation to add the total rounds of a 16 rounds. Now coming to this part, this is the extension of this particular diagram. So here we have used that F box over here. Now we are discussing that what basically a function will be consisting of. So in that function part, you can see that we have a 32-bit data. Under this particular function part, again there is an expansion box. This expansion box will expand this 32-bit data to 48-bit data. This expansion box will expand your 32-bit data to 48-bit data. Okay? And with the help of a key 1, that is a 48-bit key 1, you will be performing that exclusive OR operation on both these parts. So you will be getting the output in the form of a 48-bit. But still your Here you can see that we are having 32-bit. So your output should be here also 32-bit. Then only you can perform the exclusive output. Okay. So here what you have done, whatever the output you are getting over here, that is a 48-bit. But we don't require 48-bit. We require 32-bit over here. So again, we have another box over here, that is a substitution boxes. Okay, that substitution boxes will convert your 48-bit data to the 32-bit one. And again, you will be performing some permutation on this 32-bit data. And you will be getting a 32-bit output. Now, this is the main output that you require here. Okay, so this 32-bit data plus your this 32-bit data, you will be performing that exclusive output. Fine. So this is how you can just define this particular F box. Now, one by one, we will discuss here. I hope you understood this particular diagram. Now, I need to run this part, delete this part, so that you can understand that what basically how we have expanded that 32-bit data into 48-bit data. So I just keep this second diagram on the screen, and I will explain each and every part of this particular diagram. So you can see over here that what we have done, we have used one of the expansion box here. So we have used one of the expansion box. So what we have done over here, there is an expansion box here. Okay. So what is happening in this expansion box? So what we are expanding? We are expanding a 32-bit data to the 48-bit data. Now, how we have done this? Now, let's suppose we are having some text like this. So we are using like this. Don't give them. Okay, let's suppose the option like don't give the money to that person ever. Now let's suppose this is your any text that is available to you. Now how you can expand this particular data? First of all, I will divide this particular data into blocks of a 4 bits each. So how I can write like this? Like D-O-N-T. Don't. Now next blocks is G-I-V-E. Give. Next is the, but I have to include 4 blocks, so I will be including one M with also. M. Again, that 4 blocks. O-N-E-Y. O-N-E-Y. 4 blocks. Okay. Similarly, I can have 2 TH. 2 also and TH also. Then only it can make a 4-bit data over here. Okay. Then we have TH is there. A, T, P, E. 4 blocks. R, S, O, N. Again 4 blocks. Fine. And last one is your ever. E, V, E, R. Okay. Now we are converting this data, 4 bits data to 6-bit blocks. Okay, 4-bit data to 6-bit. How it is possible? Now just skip this first part and the last part for a meanwhile. I just start explaining from this part. This is your 4-bit data. I need to convert it to 6-bit data. So I will add one more brackets here, 2 more brackets here. So its last element T, G, I, V, E. And the starting element of the next block, that is T. Fine. For this particular part, Again, I need to change it to the 6th block. So, last element of this E part, that will become the first part. E, T, H, E, M. And the first element of the next block, O. Okay. E, T, H, E, M, O. O, in the last element, we will be having the first element of the next block. And the first element of this particular one will be the last element of the previous block. Okay. So similarly, you can go to here also. Now let's suppose you can just practice it again. We are having T, O, T, H. We need to change it to the 6th block. So it's first element A. And here we will be having the last element of the previous one. That is Y. Right? Again, for this particular block, what we will be having? Here again, we will be having, we can say that last block, last part of this block, that is H, A, T, P, E, and the first element of this block, R. Okay, so this is your, so this is how we have converted a 4-bit block to the 6-bit. So this work has been done under this expansion box. ये जो expansion box है, here you can see that how we have converted 32-bit data to the 40-bit by converting a 4-bit data to the 6-bit. Now, what about this last elements? So here we are having E, B, E, R. Again, we need to convert it. So this is the first part. This two. Now, first part, there will be no issue. I will be taking the end of this particular block. Now, what about this? Because this is the end of the line. So we will be having the D over here. So we will be having the D, that is the first element. Okay. And again for this particular part. So we are having D, O, N, T. So again, there will be no issue in the last part because we will be having G only here. And what about the front part? That will be having the last part of this particular block. That is R. Okay, so that is R here. Right? So we have discussed this expansion box, like how we have converted a 32-bit data to the 40. Clear? One part is clear over here. So you can say that there were 8 blocks of 48 bits. So there is a, how we can divide this part, that we are having 8 blocks of 4-bit. So how much was the data? 32-bit. Okay. So how much data we are having? 32-bit. But now what we have done, we have converted this 8 blocks into 6-bit. So what answer that we will be having? That is 48 bits. So that's why we have got the answer of 48 bits. Clear? Now this part is also finished. Now the next thing that you might be striking to your mind, that is regarding the substitution boxes, that is the S boxes. So we have explained the expansion box. Now we will explain the substitution boxes here. So again, I just delete this particular portion of only, and I will keep this diagram for your reference. So next part that you need to understand here, that is the S boxes. Now, how many S boxes we are having? Total 8 S boxes are there. 1, 2, 3, 4, 5, 6, and 7. So total 8 S boxes are there. Now, how these 8 S boxes are working? Like they are taking 6-bit input here. 6-bit input will be there, and they are giving you 4-bit output. They are giving you 4-bit output. Okay, so 4 into 8, that will become your 32-bit. Again, you have converted your 48-bit data to 32-bit data by using the substitution boxes over here. Okay, so you have converted your 48-bit data that we have already discussed previously, that with the help of an expansion box, how we have expanded the data. That we have converted our 4-bit data to the 6-bit data and we have expanded it. Now again we are, with the help of the substitution box, what we are doing, we are converting this 48-bit data to the 32-bit data. Okay, so we are having this 32 bits data will be go into the computation box, which is the last part of this part. That will be the last part of this function declaration. Okay, so we are having this 32 bit. Now, how we have converted this 32 bit data? Now, like we can see that how to convert 6-bit data to 4-bit data. So now let's suppose we are having in S1 part, we are having a data like 0, 0, 1, 0, 1. 0, 0, 1, 0, 1 and 1. Clear? Now let's suppose this S1 is having a 6-bit data like this particular. Okay. Now what I will do, I will collect this last 2 bits over here. This is the first bit. This is the last bit. This will make my row part. Okay. And in between 4 bits will make my column part. Now in this substitution box, what will happen? We are having a standard table over here. That is a standard table that is defined in the DS part. So at that time we can have, just for your reference, I am writing the values like this: 0, 1, 2, 3, 4, 5, 6, 7, so on. Okay, so 16 till 15 we are having, and here we are having 0, 1, 2, 3. So there are some values. Just for your reference, I am writing it like this. I will be completing the full table over here. So we are having 4, 2, 1, 0, 9, 6. Okay, so that is row 0, 1, column 0, 1, 0. Okay, so row 0, 1 means according to that decimal rules, what we are having like 8, 4, 2, 1. So what will be the rule we will be having over here? So that row will be defined as a 1. Okay, so we are representing this row part as 1. So 0, 1 will be representing as 1. And here, what is the column part? That is 0, 1, 0, 1. So what value will be having? That is 5. That means first row and fifth column. So we can say that first row and the fifth column. So what value will be getting here? That is 7. Okay. So what value will be getting here? That is 7. So again, we will represent this 7 as that is 0, 1, 1, 1. So this is how I have converted my 6-bit data to the 4-bit data. How I have converted my 6-bit data to 4-bit data in the substitution boxes. What I have done, this is my 6-bit data. I will consider these 2 elements as rows and in between 4 elements as columns. So 0, 1 will give you 1 answer and 0, 1, 0, 1, 0, 1, 0, 1. What value you will be getting? 5. That means first row and fifth column over here. So what answer you are getting over here? That is 7. So again you will define that 7 word in the decimal part, that is 0, 1, 1, 1. Clear? So this is how we have converted this by using this S boxes. So how we have converted a 6-bit data to the 4-bit data. So what value you will be getting over here? You see that suspension box. So total we are having 8 boxes over here, and how many bit data is available? 4-bit data is available. So 4 into 8 will be 32 bit. This is your answer that you will be getting over here. That is 32 bit. Clear? So this is regarding the substitution boxes. Okay. So each substitution box will have a different table. So that is already mentioned in that data in this DS. So each substitution boxes will be having a different table. Now we are left with the last part of this data encryption standard, that is the key part. So we have come to know that how we can perform this combination. Firstly, we have converted our data to 64-bit, then we have converted to 32-bit, then 48-bit, again from 48-bit to the 32-bit. But now the last thing that is left over here is that the key part. So this will tell you, we will explain that how keys will be generated over here. So I will go to this part. So I'm going to place all this content because this key structure is somehow different from all this part. So that is a unique portion in any type of algorithm, that is a key generation. So you must understand that in case of a data encryption standard, how you can use all these keys parts. And how, firstly, we will see that how these keys will be generated over here. Okay. So actually, what happens? If you remember my very first diagram, in that particular diagram, what we have discussed so far, that initially we are having a 64-bit key. If you remember my very first diagram, in that part, I have already defined we have a 64-bit key. We convert the 64-bit key to 56-bit key, and again we convert it to the 48-bit. Now this 48-bit key will move towards that particular function blocks, and by doing all those combination and after doing exclusive OR with the left 32-bit, this is how we can use this 48-bit key. Clear? If you remember just my first diagram, so here you can see that firstly a key will be initially of 64-bit. Initially it will be 64-bit key. Now here we have PC1. Here we will use one term, that is PC1, that is permuted choice 1. PC refers to permuted choice 1. That is permuted choice 1. Fine. Now, when we move the 64-bit key to PC1, what will happen? It will give you output as 56-bit. Okay. It will first convert it to 56-bit. How it will be converting? It will be discarding the last bit of each block. Now, what will happen? We have converted the 64-bit part into 8 parts. So total we will be having 1, 2, 3, 4, 5, 6, 7, 8. So we have divided this particular key into 8 different blocks. That is starting from 1 to 8, 9 to 16, so on, and the last part will be 58 to 60. Now, how we have changed a 64-bit block to 56 block or to 56-bit block, we will discard the last element of each and every block. So whatever the element that belongs to this particular part, we will discard all those blocks. We will discard all those bits that will be available in a particular block over here. Like 8, 16, any multiple of 8. So all these 8 bits will be the factors of that 8. Okay. So we have discarded all this part, 8, 16, 24, 32. So that will be my last bit. So after discarding all these 8 bits, what answer we will be getting here? That is 56 bits. What answer we will be getting here? That is 56 bits. Now, what we will doing in this 64-bit, we will be dividing this part into 2 parts. One is a C0 and another one is a D0. Okay. Now, this C0 will be also 28-bit and this D0 will be also 28. And we will be having that shift over here. Shift operation that we will be performing over here. Here. And on this shift part, again, we will be performing the left shift over here. And finally, whatever the answer, again, we will be having C1 and D1. Again, we will be performing that shift over here. Okay. So total, how many shifts we will be following? That is the 16 shift will be there. how many shifts we will be following? That is a 16 shift we will be having. So it will work till C16 and D16. Okay. So this shift will be occurred. Fine. So after performing all these things part over here, so what we will do here, like here in this particular one, now how this shift will occur? So what type of a shift? One shift, two shift, three shift. So how we can define all this shift operation? So for the rounds I equal to 1, 2, 9, 16, we will perform one shift. That means for this is my one round. Similarly, two round, we will be having that one shift. And if my value of I is 0, or we will represent 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, and 15. We will be performing a 2-bit shift over here. We will be performing a 2-bit shift over here. Fine. So this is a rule that you must need to remember over here. Now just remember, when you will move to this path, that is C1 and D1, again you will be having a 56-bit data, and you will be giving this particular data to PC2. That is permitted choice 2. Again, this 56-bit data will be converted to 48-bit data by following the same concept, that you will be skipping all the last element of this particular. Okay, so this is how your 48-bit will be generated. So this is the thing that we require. Initially we have 64-bit, again we have converted to 56-bit, and again we have converted to 48-bit. 64-bit, 56-bit, in which we have discarded all the last elements. We have two parts over here of this 56-bit, and we are performing shift operation on each and every part. So whatever the output that we will be getting over here, we will combine that particular part, and again we will give to PC2, that is permanent combination 2. And here we will again skip the last elements over here. And finally we will get the 48-bit TU. So this is the way how we can get that 48-bit TU. Okay, so finally your output will be available at this 48-bit. Okay. So here also there is a rule, like we have a left part and we have a that is a right part. So the position bits are removed from the left side and position bits are removed from the this particular side. Okay, so left half and the right half. So these are also like for C1, we will be having different nomenclature that we will remove bits. Total, how many bits we need to remove? This was 56-bit. Total, how many bits we need to remove in order to convert it to 48 bits? Total 8 bits. So you just remember that is for C1 part, which particular position bit we need to remove? 9, 8, 22, 21. Okay. So this bit should be removed in under this C1. Here in the case of a D1, which position number we need to remove? 35, 38, 43, 52. 4 plus 4, 8 bits. So total 8 bits, we will remove that 8 bits over here, and finally we will get the 48-bit key. The first key is generated like this. Clear? So first key will be generated like this. This is how we can define that. This is the like a main thing that you need to remember in the case of a data encryption standard. So this was all about data encryption standard. Hope you understood this part. So I tried my best to just discuss and explain you each and every part in a more in a thoroughly way. Still, if you feel like anything discussing with me, we can discuss it afterwards.